Well, these three things will help us to predict the strength of acid or base. That is acid ionization constant Ka or pKa and base ionization constant Kb or pKb values. The next is for oxy acid, oxygen number help us how many oxygen are there in an oxy acid. And the other is the periodic trends of the electronegativity in group and period. Such things help us to predict the strength of acid or base. Question that which acid is stronger? That is HF and HCN, and we are given with their acid ionization constant value Ka. For HF, it is 7.2 into 10 power minus 4, and for HCN, it is 6.2 into 10 power minus 10. Remember, the clue for such question is that this acid ionization constant Ka is directly proportional to strength of acid. Strength of acid. An acid having higher value of K will be stronger acid. Now, looking at these two values, 10 power minus 10, it is very small value, and 10 power minus 4 is a large value. So here HF is stronger acid than HCN. So the clue is that Ka directly proportional to strength of acid. HNO3 and HNO2. HNO3 is nitric acid and HNO2 is nitrous acid. Now, which acid is stronger? Remember, such acids are known as oxy acids containing oxygen, and the acid with more number of oxygen will be the stronger acid. For example, over here, HNO2 nitric acid is stronger than HNO2 nitrous acid. So HNO3 is stronger than HNO2. Similarly, we have a lot of other oxy acids. For example, that is perchloric acid, HClO4. It is stronger than HClO3. It is stronger than HClO2 and stronger than HClO. So again, the number of oxygen increases, the strength of acid also increases. Another example is that of sulfuric acid, H2SO4 is stronger than H2SO3. That is sulfuric acid, sulfurous acid. Another is phosphoric acid, H3PO4. It is stronger than phosphorus acid, H3PO3. So such type of acids are known as oxy acid. So the acid having more oxygen will be the stronger acid. In this question, we are asked to find out the strongest base, a stronger base. Ammonia NH3 and methylamine, these are the two bases. Their Kb values are given. Again, Kb value is directly related to basicity or basic strength. If Kb value is higher, the base is stronger. In these two values, if we compare these, 10 power minus 4 is higher value, 10 power minus 5 is lower value. It shows that methylamine CH3NH2 is stronger base than ammonia according to the base ionization constant values. Question is here that which acid is stronger, HBr or HI? So remember, these are binary acids of hydrogen. The binary acids of hydrogen has a periodic trend. If we move from right to left in a period, or from left to right in a period, and from top to bottom in a group, remember the acid strength increases and while moving from left to right in a period, and the acid strength also increases from moving top to bottom in a group. So if we look at the period, we are getting carbon, nitrogen, oxygen, fluorine. In fluorine halogen group, we are getting chlorine, bromine, and iodine. So according to this trend, we can say that the strongest acid is HF in the period. That is, HF is stronger acid than H2O, that is stronger acid than NH3, and stronger acid than CH4. This is a trend in a period. Now in the group like that of halogens, this one, down the group the acidic strength increases. So we can say that hydrogen iodide is stronger acid than hydrogen bromide, stronger acid than hydrogen chloride, and stronger acid than hydrogen fluoride. So this is a trend for binary acids of hydrogen. Moving along a period from left to right, acidic strength increases, and moving in a group from top to bottom, acidic strength increases. Find out the stronger acid in HClO and HIO, that is hypochlorous acid and hypoiodous acid. In the binary acid, if we look at the halogen group, that is HF, HCl, HBr, and HI, we are getting the strength as HI is stronger than HBr, HBr is stronger than HCl, and HCl is stronger than HF. But in oxy acid, the trend is reversed, means that HIO will be weak acid than HBRO, hypobromous acid, weak acid than HClO, and fluorine does not form such type of acid because it can never exist in positive oxidation state. So in this example, the electronegativity answers. The more electronegative is the halogen, the more strength will be of that acid. So there the answer is that HClO, hypochlorous acid, and stronger than HIO, hypoiodous acid. In this question, we are asked to find out the stronger base. Looking at the given examples, HS negative, it is the conjugate base of H2S. When H2S ionizes, it gives hydrogen ion aqueous and HS negative conjugate base. Acid produces a conjugate base and a base produces a conjugate acid. This is a reversible process. The next is HNO2. HNO2, nitrous acid, ionizes to give hydrogen ion and the conjugate base nitrite, and this is backward reaction. Now, for such question, remember that a stronger acid, if it is, will produce a weak base, W for weak, B for base, and vice versa. If a weak acid, it will produce a strong conjugate base. Here, how we can find that which acid is weak and strong? Look at these Ka values, acid ionization constant. These values will help us. Looking at the value for H2S, it is 10 power minus 7, and for HNO2, it is 10 power minus 4. Minus 4 is larger value, means that HNO2 is stronger acid. HNO2 is stronger acid than H2S. Now, this stronger acid will give a weak conjugate base, and compared to HNO2, H2S is weaker, so it will produce a strong base. So the two, that is NO2 negative conjugate base and HS negative conjugate base. Here, stronger base is HS, so NO2 is weaker base compared to HS negative. Another question, stronger acid to find, that is HClO and acetic acid CH3COOH. We are asked that which one is stronger acid, and we are given values pKa instead of Ka, acid ionization constant. So the rule of thumb for this is that pKa is inversely related to strength of acid. An acid with a large pKa value will be the weaker acid, and vice versa. If you compare both the values, HClO has a larger pKa value, that is 7.46, and acetic acid has 4.74. These values shows that this is the smaller value, so acid will be the stronger. So acetic acid CH3COOH is stronger than hypochlorous acid HClO.